In mathematics, a polynomial is an expression consisting of variables and coefficients that involves only the operations of addition, subtraction, multiplication, division, and exponentiation to non-negative integer powers, and that has a finite number of terms. Hello everyone, welcome to my channel. My name is Rafael. I am an analytical engineer and bilingual teacher of mathematics and physics from Brazil, and in this video I'd like to discuss with you the solution of 9 questions on single variable polynomials. Let's go to the first exercise. Exercise number 1 says, if p of x is equal to x cubed minus 5x squared plus 3x plus 6, what is the value of p of 4? Okay, my friends, this is the exercise. Let's go to the solution. This is a simple question just to introduce us to the topic of polynomials. And the question wants us to find the value of p of 4. What can we do? We simply substitute 4 in the place of x in the expression of the polynomial. Okay? So we are going to use x equal to 4 in the expression of the polynomial, 4 in the place of x. Alright? This is how we solve this question. P of x equal to 4 is equal to, we are going to use 4 in the place of x. 4 cubed minus 5, 4 squared plus 3 times 4 plus 6. Okay? This is how we do it. 4 cubed is 64 minus 5 times 4 squared is 16 plus 3 times 4 is 12 plus 6. Okay? Continuing, 64 minus 5 times 16 is 80 plus 12 plus 6. 64 plus 6 is 70 plus 12, 82 minus 80 is equal to 2. Okay? Consequently, p of 4 is equal to 2. Alright? And this is the solution of exercise number 1. Okay, my friends, this was exercise number 1. A very easy exercise. Let's go to the next. Let's go to exercise number 2. Exercise number 2. If p of x is equal to x squared plus 6x plus 11, then what is the value of p of a minus 3? Okay, my friends, this is exercise number 2. Let's go to the solution. To find the value of p of a minus 3, we simply substitute x equal to a minus 3 in the expression of the polynomial. Okay? This is what we are going to do. P of a minus 3 is equal to, we substitute not only a, not only negative 3, we substitute this entire term in the place of x, okay? Then it is a minus 3 squared, okay? Could you comprehend? I inserted a minus 3 in the place of x plus 6 times a minus 3 plus 11. Now it is mathematics only. There is a product here. We need to develop it. It is going to be a squared minus 2 times a times 3. Then it is negative 6 times a plus 3 squared. 3 squared is 9. Plus 6 times a, 6a, 6 times negative 3, negative 18. Plus 11. Continuing, we find a squared. I can simplify negative 6a with positive 6a. They cancel each other out. And we have here positive 9 with negative 18, negative 9, okay? Positive 9 with negative 18, negative 9 plus 11. 11 minus 9 is positive 2. Okay? Then the solution of this exercise is a squared plus 2. Alright, my friends, did you understand what I did? I substituted a minus 3 in the place of x. It became a minus 3 squared. I substitute a minus 3 in the place of x here. It became 6 times a minus 3 plus 11. And we carried out this algebraic manipulation and we found a squared plus 2. Okay, my friends, this is all for exercise number 2. Let's go to the next. Exercise number 3 now. If p of x is equal to x squared minus 2x minus 2, what is the value of p of 1 plus the square root of 3? Okay, my friends, this is the exercise. Let's go to the solution. All we need to do is to simply use 1 plus the square root of 3 in the place of x, as we did in the previous exercises. Let's do it. X equal to 1 plus the square root of 3. We are going to insert this in the expression of the polynomial, alright? So p of 1 plus the square root of 3 is equal to 1 plus the square root of 3 squared minus 2 times 1 plus the square root of 3 minus 2, okay? Simple, isn't it? All we needed to do was to put 1 plus the square root of 3 in the place of x. Now we have simple mathematics. And there is a product here. Let's develop the product. Developing this, we find 1 squared is 1 plus 2 times 1 times the square root of 3 is 2 square root of 3 plus the square root of 3 squared. Okay? Continuing, negative 2 times 1 is negative 2. negative 2 times the square root of 3 is negative 2 times the square root of 3 minus 2. Okay. Let's work on this. Okay. 1 plus 2 times the square root of 3 plus the square root of 3 squared is 3. Okay? Minus 2 minus 2 times the square root of 3 minus 2. Observe that we can simplify this with this, okay? They cancel each other out. Observe also that 3 plus 1 is 4. And that negative 2 with negative 2 is negative 4. And this subtraction results in 0. Alright? Then the solution of this exercise is 0. Okay? Simple, isn't it? That's all, my friends, for exercise number 3. Let's go to the next. Exercise number 4 now. If p of x is equal to x squared minus x plus 1 and q of x is equal to x squared plus x minus 1, find in letter A p plus q, in letter B p minus q, in letter C p times q, in letter D the remainder of the division between p squared and x minus 1, and in letter E the remainder of the division between p and q. Okay, my friends, this is the question. Let's go to the solution. Let's begin with letter A. The exercise wants us to sum p with q. We simply do it. P of x plus q of x. We write p x squared minus x plus 1, and we sum with q. We write q x squared plus x minus 1. Okay? Simple, very easy. We simply write the polynomials. As it is addition, then we don't change the signs. X squared plus x squared is 2x squared. Observe that we have a negative x here and x here. They cancel each other out. Observe also that we have a positive 1 here and a negative 1 here. They cancel each other out. Therefore, the solution of letter A is 2x squared. Alright? Let's go to letter B now. Letter B. P minus q. P of x minus q of x is, we write p x squared minus x plus 1 minus q. We write q x squared plus x minus 1. Observe that now there is a negative sign here. It means that the signs here inside of the parentheses will change. Therefore, it is equal to x squared minus x plus 1 minus x squared minus x plus 1, okay? This was positive, it became negative. This was positive, it became negative, and it was negative, and it became positive, okay? Consequently, we can simply sum them. Sum them now. Observe that this x squared cancel with this. They cancel each other out. And we have negative x here and negative x. Negative x with negative x, negative 2x. Okay? And observe that we have 1 plus 1. 1 plus 1 is 2. Then the solution of letter B is negative 2x plus 2. Okay? This is all for letter B. Let's go to letter C now. Letter C. What does letter C want us to do? To multiply P with Q. P of x times Q of x is equal to x squared minus x plus 1 times x squared plus x minus 1, okay? All we need to do is to multiply each term of this with each term of this, okay? This is how we multiply polynomials. Then it is going to become x squared times x squared, x to the fourth, x squared times x is x cubed, x squared times negative 1, negative x squared, now we move on to this term, negative x times x squared, negative x cubed, negative x times positive x is negative x squared, negative x times negative 1 is positive x. Lastly, we multiply every term by 1. 1 times x squared is x squared, 1 times x is x, and 1 times negative 1 is negative 1. Observe that we have only one x to the fourth here, then we repeat it. We have two terms here raised to the third power, here and here. This is positive, this is negative, they cancel each other out. X cubed minus x cubed, 0. Observe here that we have negative x squared and positive x squared, they cancel each other out. But I have here negative x squared. I repeat it. X plus x is 2x, and there is a negative 1 here. We repeat it. Okay? Then the solution for letter C is x to the fourth minus x squared plus 2x minus 1. Okay, my friends? Let's go now to letter D. Letter D now. The exercise wants us to find the remainder of the division between p squared and x minus 1. Let's go, let's do it, but firstly we need to find p squared. P squared is equal to p of x times p of x, okay? And as we did for letter C, we simply multiply, but now p of x by itself, okay? We are going to do it x squared minus x plus 1, x squared minus x plus 1, okay? This is the multiplication that we need to perform. X squared times x squared is x to the fourth. X squared times negative x is negative x cubed. X squared times 1 is x squared. Moving on to negative x now. Negative x times x squared is negative x cubed. Negative x times negative x is positive x squared. Negative x times 1 is negative x. Moving on to 1. 1 times x squared is x squared. 1 times negative x is negative x, and 1 times 1 is 1, okay? Now we add the terms. We have only one x to the fourth. We simply repeat it, x to the fourth. We have negative x cubed, then it is equal to 2 times x cubed. We have 1, 2, 3 x squared, then it is equal to 3x squared. And here we have 1, 2, negative x, then it is negative 2x plus 1, okay? All we need to do now is to divide. Divide x to the fourth minus 2x cubed plus 3x squared minus 2x plus 1 by x minus 1, okay? I'm going to erase the board here for some room to carry out this division, okay? Let's go. Let's divide one by the other. X to the fourth minus 2x cubed plus 3x squared minus 2x plus 1 divided by x minus 1, okay? Let's do it. Let's divide. X to the fourth divided by x is x cubed. X cubed times negative 1 is negative x cubed. I pass to this side, it becomes positive x cubed. X cubed times x is x to the fourth. I pass to this side, it becomes negative x to the fourth. Okay? These terms cancel each other out. I have here negative 2x cubed and x cubed. They become negative x cubed. I will need this term. I pass this below. Okay? Continuing the division, negative x cubed divided by x is negative x squared. Negative x squared times negative 1 is positive x squared. When I pass to the other side, it becomes negative x squared. Negative x squared times x is negative x cubed. I pass to this side, it becomes positive x cubed. These terms cancel each other out. 3 minus 1 is 2x squared. I will need this, then I write it down here. 2x squared divided by x is 2x, positive 2x. 2x times negative 1, negative 2x. I pass to this side, it becomes positive 2x. 2x times x is 2x squared. I pass to this side, negative 2x squared. They cancel each other out here and here. Then I have a 0, but I still have a 1 here, okay? Then plus 1. Then we find that the remainder is 1, okay? The remainder is 1. This is the solution of this exercise. The remainder is 1. This is what the exercise wanted from us. But there is an alternative way of solving this exercise. Instead of dividing, we can find this remainder here using a different way. I'm going to show you. Let me erase it here and I will show you how to find this remainder in a different way, in an alternative way, okay? The second way of solving this exercise is to apply x equal to 1 to the equation of p squared. Okay, the equation of p squared was p squared of x, x to the fourth, minus 2x cubed plus 3x squared minus 2x plus 1. Okay? If p squared is divisible by x minus 1, they share roots, okay? And the root of this polynomial is also the root of p squared, okay? Let's suppose that this polynomial here is h of x equal to x minus 1, okay? What is the root of this polynomial? The root of this polynomial occurs when h of x is equal to 0. Consequently, x minus 1 equal to 0, x is equal to 1. This is the root or the 0 of this polynomial here, h of x equal to x minus 1, okay? This is the root, but if p squared of x is divisible by h of x equal to x minus 1, they share this root. 1 is a common root of this and this polynomial. But what if, I'm going to ask you, what if p squared of x is not entirely divisible by x minus 1. This is the trick. This is the idea. This is the insight. If this is divisible by this is a root, a common root. But what if it is not? What if this polynomial is not divisible by this entirely? What if there is a remainder of this division? The remainder of this division, when I apply x equal to 1 in the polynomial, will appear somehow. Let's see how the remainder appears. P squared of x equal to 1 will be equal to 1 to the 4th minus 2 times 1 cubed plus 3 times 1 squared minus 2 times 1 plus 1, okay? 1 to the 4th is 1, 2 times 1 is 2, 3 times 1 is 3, 2 times 1 is 2, and 1. Summing the positive terms, 1 plus 3 is 4, plus 1 is 5. Summing the negative terms, negative 2 with negative 2, negative 4. And this is equal to 1. Observe that they are not divisible by each other. Observe that the p squared of x is not divisible entirely by x minus 1. If p squared of x were divisible by x minus 1, when I apply the root of h of x equal to x minus 1, the result would be 0 here, not 1. This result here is the remainder of the division, okay? This is the remainder of the division. One more time. When this polynomial is entirely divisible by this, they share a common root, okay? If I apply the root in this polynomial, I should obtain a 0, but as we saw, this polynomial is not entirely divisible by this, and when I apply the root of this polynomial here, instead of getting a 0, I get the remainder of the division, okay? This is the alternative way of understanding this problem. Alright, my friends, this is all for letter D. Let's go to the last. Let's go to letter E. Letter E now. Find the remainder of the division between P and Q. Okay? We are going to do it. We are going to divide one by the other. We simply divide x squared minus x plus 1 by x squared plus x minus 1. Okay? X squared divided by x squared is 1. 1 times negative 1 is negative 1, passing to the other side, positive 1. 1 times x is positive x, passing to the other side, negative x. 1 times x squared is x squared, passing to the other side, negative x squared. Cancel each other out, then it becomes negative 2x plus 2, okay? And the exercise 1 is asked to find the remainder, and the remainder of the division is this. This is the remainder of the division, okay, my friends? It is all for exercise number 4. Let's go to the next. Let's go to exercise number 5. Exercise number 5 now. What is the quotient of the division between P of x and the Q of x? Okay, my friends, this is exercise number 5. All we need to do is to simply, as we did previously, divide the P of x by Q of x. Okay, let's go to the solution. we are going to simply divide 5x to the fourth minus 3x squared plus 2x plus 1 divided by x squared minus 2x plus 3. Okay? Let's go. Let's divide 5x to the fourth divided by x squared is 5x squared, okay? 5x squared times 3 is 15x squared. Positive, passing to the other side, it becomes negative 15x squared. 5x squared times negative 2x is negative 10x cubed. Passing to the other side, it is positive 10x cubed. 5x squared times x squared, positive x to the fourth. Passing to the other side, negative 5x to the fourth, okay? These cancel each other out. I have only one term in x cubed, then I repeat it, 10x cubed. Negative 3x squared with negative 15x squared is negative 18x squared, okay? I pass this positive 2x below here to help our division. 10x times 3 is 30x. Pass to the other side, negative 30x. 10x times negative 2x is negative 20x. Pass to the other side, positive 20x squared. One more time. 10x times negative 2x is negative 20x squared. Negative 20x squared. I pass to the other side, positive 20x squared. 10x times x squared is positive 10x cubed. Pass to the other side, negative 10x cubed. These guys cancel each other out. 20 minus 18 is 2. 30 minus 2 is 28, but it is negative here and positive here, then it is negative 28x, okay? I pass this one below here and continue the division. 2x squared divided by x squared is 2. 2 times 3 is 6. I pass negative 6. 2 times negative 2x is negative 4x. Pass to the other side. Positive 4x. 2 times negative 2x is negative 4x. Pass to the other side. Positive 4x. 2 times x squared is 2x squared, pass to the other side, negative 2x squared. Negative 28x plus 4x is negative 24x, 6. Negative 6 plus 1 is negative 5. Therefore, the quotient is 5x squared plus 10x plus 2, and the remainder is negative 24x minus 5. Okay, my friends, this is all for exercise number 5. Let's go to the next. Let's go to exercise number 6. Exercise number 6. What is the quotient of the division between P of x and Q of x? What are the roots of this polynomial? Alright, my friends, let's go do it. The exercise wants us to divide this by this, okay? X cubed plus x squared minus 10x plus 8 divided by x minus 2. X cubed divided by x is x squared. X squared times negative 2. Negative 2x squared pass to the other side, positive 2x squared. X squared times x is x cubed. Pass to the other side, negative x cubed, okay? We just sum them. These terms cancel each other out. 2 plus 1 is 3x squared. Write this 10x. 3x squared divided by x is 3x. 3x times negative 2 is negative 6x. Pass to this side, positive 6x. 3x times x is 3x squared. Pass here, negative 3x squared. These terms cancel each other out. Negative 10 plus 6, negative 4x. I use this 8 here. Negative 4x divided by x is negative 4. Okay? Negative 4 times negative 2 is positive 8. I pass negative 8. Negative 4 times x is negative 4x. I pass positive 4x. They cancel each other out, and the remainder is 0, okay? So the exercise asked us, what is the quotient of the division between this and this? And the quotient is exactly this. This is the quotient. Alright, let's call it h of x, okay? The second question is, what are the roots of this polynomial? Let's go do it. Let's find the roots of h of x. H of x is equal to x squared plus 3x minus 4. We are going to use the quadratic formula to find the roots. X is equal to negative 3 plus minus the square root of 9 minus 4 times negative 4 divided by 2, okay? This is the quadratic formula, okay? It is negative this plus minus the square root of this minus 4 times this divided by 2 times this, okay? And this is equal to negative 3 plus minus 5 divided by 2. We repeat this negative 3. 4 times 4 is 16. Negative, negative, positive. Positive 16 with 9 is 25. The square root of 25 is 5, okay? The first root is negative 3 plus 5 is positive 2 divided by 2 is 1, and negative 3 with negative 5 is negative 8 divided by 2, negative 4, okay? So these are the roots of this polynomial. Alright, my friends, and this is all for question 6. Let's go to the next. Let's go to question 7. Exercise number 7 now. If P of x is divisible by Q of x, what is the value of A? Okay, my friends, this is the exercise. Let's go to the solution. Observe that if P of x is divisible by Q of x, the exercises say that the statement is this. The exercises say that the P of x is divisible by Q of x. Consequently, if one is divisible by the other, then they share roots, alright? Thus, the root of Q of x is also a root of P of x. We discussed this previously. We said that if one is divisible by the other, then the root of this polynomial is also a root of this polynomial. But in that occasion, we say that if P of x is not divisible by Q of x, then when I apply the root of Q of x in P of x, I find the remainder, okay, not 0. Alright? But if the root of Q of x is also a root of P of x, then when I apply the root of Q of x in P of x, instead of finding the remainder, I will find inevitably 0, okay? Because it is a root. Alright, then let's discover the root of Q of x. Q of x equal to x minus 3. The root is that in which Q of x is equal to 0. Consequently, x minus 3 is equal to 0, x is equal to 3, okay? This is the root of Q of x. If I apply this root here, I shall find 0. Consequently, 3 cubed minus 8 times 3 squared plus 8 times 3 minus 15 has to be 0. Alright? This is the main understanding to find the solution of this exercise. Subsequently, we carry out this operation. 3 cubed is 27, 3 squared is 9, plus 3a minus 15 equal to 0. Negative 9 with positive 3 is negative 6. (27 minus 15 is 12. Okay? As a consequence, A is equal to 2. And this is precisely what the exercise wanted us to calculate. Okay? Alright, my friends, this is all for exercise number 7. Let's go to the next. Exercise number 8. If P of x is divisible by D of x, what is the value of A plus B? Alright, my friends, this is exercise 8. And we are going to proceed as we did previously. Okay? The idea is this. If P of x is divisible by D of x, then the remainder is 0. And what does it mean? It means that if I use the roots of D of x in P, I will find 0, okay? Because if one is divisible by the other, they share roots, they have common roots, okay? And the root of D are the value or values that cause D of x to be equal to 0, okay? This is the definition of a root. A root is a value that makes D of x equal to 0. But if they share roots, then the number, the root that makes D of x equal to 0 will also make P of x equal to 0, okay? We saw that if it is not the case, then the root of this, instead of producing 0, will produce the remainder of the division between this and this, okay? Then let's go, let's find it, okay? D of x equal to 0, okay? We are going to find the root of D of x by making it equal to 0. Consequently, x squared minus x minus 2 equal to 0. We are inspecting the polynomial D of x to find its roots. X is equal to 1 plus minus the square root of negative 1 squared minus 4 times 1 times negative 2 divided by 2, okay? And in this way, it is 1 plus minus negative 1 squared is 1. 4 times 2 is 8. Negative with negative, positive, positive 8 with positive 1 is 9. Then we are calculating the square root of 9. The square root of 9 is 3 over 2. The first root is x1 equal to 1 plus 3 is 4 divided by 2, it is equal to 2. The second root, x2, 1 minus 3 is negative 2 divided by 2, negative 1. These are the roots of D of x. If they make D of x 0, they will also make P of x 0, okay? This is the idea of the exercise. Let's save them here, because we need to erase the board for some room. Okay, let's apply x equal to 2 in P. P of x equal to 2 is equal to 2 to the fourth minus 3 times 2 cubed plus 5 times 2 squared plus 2 times a plus b, okay? And this, as we saw, this has to be 0, okay, because we are assuming that 2 is a root of this polynomial. Then it has to be equal to 0. Then we find that 2a plus b plus 12 has to be equal to 0. Now let's apply -1 here. It is going to become -1 to the fourth minus 3 times -1 cubed plus 5 times -1 squared plus -1 times a plus b, okay? And this has to be equal to 0 because -1 is a root. Then we find -a plus b plus 9 equal to 0. We've got here a system of equations. 2a plus b plus 12 equal to 0. -a plus b plus 9 equal to 0. It is easy to solve this system of equations. We can simply multiply this by 1, okay, by -1. Then the system is going to be, I'm going to multiply the second equation by -1. 2a plus b plus 12 equal to 0. A minus b minus 9 equal to 0. We can simply sum them. These guys cancel each other out. 3a 12 minus 9 is 3. Thus, we find that a is equal to -1. Now I can use any equation to find the value of b. From this, I find that b is equal to a minus 9. Okay? I pass this b to this side. Now, I keep b here. I pass -8 to the other side. It becomes positive a. I pass positive 9 to the other side. It becomes -9. Then it is SA is -1. Okay? These are the values of A and B. But the exercise wanted A plus B. A plus B is equal to -1 minus 10. And this is equal to -11. Alright? And this is the solution of exercise number 8. Alright, my friends, let's go to the last exercise. Let's go to exercise number 9. Exercise number 9. If P of x is divisible by D of x and the quotient is Q of x, what is the value of K? Alright, my friends, this is the exercise. Let's go to the solution. The exercise imposes that the P of x is divisible by D of x. And what does it mean? It means that they share roots, okay? They have common roots, these two polynomials, okay? we have a k here, then we cannot find directly the roots of p, but we can find the root of d, okay? And how can we find the root of d? We make it equal to 0, d of x equal to 0, we find the root, x minus 2 equal to 0, x equal to 2. 2 is the root of d of x, because if I put 2 here, 2 minus 2 is 0, okay? 2 is a root of d of x, is the root, okay? The only root. 2 is the root of d of x. But this 2 is also a root of p of x, because the exercise imposed that p of x is divisible by d of x. Then they share this root here. And what does it mean? It means that if I apply 2 in this polynomial, it has to make it equal to 0, okay? Consequently, 2 to the 6th minus 30 times 2 plus k has to be equal to 0, alright? 2 to the 6th is 64, minus 30 times 2 is 60, plus k equal to 0. 64 minus 60 is 4, plus k equal to 0, then k is equal to negative 4. Alright? And this is all the exercise wanted us to calculate. Okay, my friends? And this was the video that I wanted to make about polynomials. I hope you enjoyed it and learned from it. I'm a teacher, guys. If you want to book a lesson with me, use my WhatsApp number. Goodbye!